Alright, let's do some homework. So this is from lesson 4.2. We're going to talk about lesson 4.2 more, specifically about drawing these angles. But I'm going to go ahead and work through all this in the homework. So, these first 5 are some thinking questions. You are required occasionally to use your brain in pre-cal, as in the rest of life. So let's try this. So how many degrees does the hour hand move each hour? Well, first let's think about how far the hour hand moves each hour. So let's say it's noon, so it's going to start there. The hour hand is going to go from there, to the 1. How far is that? Okay, well, how many degrees are in a full circle? 360. And how many hours are in a full circle? 12. So if I divide that 360 into 12 different pieces, then each hour is 30 degrees long. Yeah. Okay, how many radians is that? Well, the full circle is 2 pi. And if I cut that up into 12 pieces, then each hour is, and I can reduce that fraction, pi divided by 6. Done. How many radians does the minute hand move each hour? Well, the minute hand goes all the way around the clock each hour. So that's an entire circle, 2 pi. What about the second hand? How far does it move each hour? Well, it goes around the full circle each minute, and that's going to happen 60 times each hour. So it goes 60 full circles. So 2 pi times 60. And if you didn't understand this question, it's I want you to answer the same question. How many radians does the second hand move each hour? So it's going to go 120 pi radians. If you're curious, what would that be in degrees? You just multiply 60 by 360. So the minute hand moves 12,960 degrees each hour. The busy life of the second hand. E. How many degrees will the minute hand move during this class? This doesn't really make sense as a homework problem, but okay, let's pretend this is a 90-minute class. So if this is a 90-minute class, like most of my classes are, then the minute hand is going to move, so 60 minutes would be 1 circle, and then 90 minutes would be 1.5 circles. So how many degrees is that? Well, it's 1 full circle, 360, plus 1/2 circle, 180, which is 540 degrees. Okay. Number 2, we're going to draw some angles. So when I say draw an angle, basically we're figuring out where our rotation would stop. So if we start at 0, where do we stop? And I'm going to draw a line in that spot. So 300 degrees. So if you remember, this is 180 here. We're counting in degrees. So there's 180, there's 90, there's 270. So which quadrant is it going to be in? And this is 360 also. Well, it's going to be in the 3rd quadrant. Is it going to be closer to the 4th quadrant? That's over here. Is it going to be closer to 270 or to 360? It's closer to 270, so it's going to be there-ish. It's 30 degrees past 270. What about 225? Well, it's bigger than 90, it's bigger than 180, but it is not bigger than 270, so that means it's going to be in here somewhere. Where? Well, 225 is exactly in the middle. It's 45 away from 180, and it's also 45 away from 270. So there's my angle right there. 120 degrees. How much rotation is that? Have a good weekend. There's 90. There's 180. So it's going to be in between those. It's in the second quadrant. Which one is it closer to? It's closer to 90. In fact, it is 30 degrees past 90. So that's where 120 degrees is. I'll come back and convert to radians in a second. 45 degrees, where is that? So there's 0, there's 90, and we have already trapped 45 degrees. It's in between 0 and 90, where? Exactly halfway in between them. Now, let's think about these as radians. Okay. So 300 degrees, we said, is 30 degrees past 270. So this is a multiple of 30. So when we counted by 30 degree marks, what were we counting by in radians? We were counting by sixths of pi. So there's 30, 60, 90, like that, etc., etc., etc. But I'm going to count in sixths of pi. So there's 1 sixth, 2, 3, 4, 5. There's 6 sixths of pi. 7, 8, 9 sixths. So it's 10 sixths of pi. 1, 2, 3, 4, 7, 9, 10. Which reduces to 5 pi over 3. That's all you got to do. Figure out what you're supposed to be counting by, and then count. 225. Okay, so this one is a multiple of 45. It's 45 degrees away from the axes. So 45 degrees, that's where we were counting by pi over 4. 45 degrees would be a fourth of a half of a circle. So there's 1/4, 2/4, there's a half pi, 3/4, 4/4, there's pi, 5/4. So it's 5/4 of pi. Where's 120? So 120 is 30 degrees away from 90, so we need to be counting by our 30s, which in radians is sixths of pi. So here's 1, 2, 3. Remember, the sixths are like the hours on a clock. So we're going to have 12 of those going all the way around. So we're going to have 1, 2, 3 in each quadrant. So there's 1, 2, 3, 4 sixths of pi, which reduces to 2/4. What about 45 degrees? Well, 45 degrees, pi is a half circle. This would be a fourth. So it's pi over 4. Okay. Let's try the same thing on part B. 7 pi over 6. So to get to this angle, we're going to count by sixths of pi, just like we do here. So I know that I have pi, I've got half a pi there. I've got pi over here. But it doesn't necessarily help me find 7/6 pi unless I count. So I'm going to count 1, 2, 3. So remember, sixths of pi are like the hours on a clock. 1, 2, 3, 4, 5. There's 6 pi over 6, which is pi, and then 7 pi over 6 would be another pi over 6 past that. So it is that much rotation right there. What would that be in degrees? Well, pi over 6 is 30 degrees, and it's 30 degrees past 180. That's 250. What about 3 pi over 4? So this time we're counting by fourths. Those are the 45 degree angles. So there's a 45 degree angle. So there's 1/4, 2/4, 3/4, and we're done. We found it. 3/4 of pi. And this would be 4/4 of pi. We didn't have to go that far. What is that in degrees? Well, instead of counting by fourths, we're counting by 45. So there's 45, there's 90, there's 135. It's 135 degrees. 3 pi over 2. So here we're counting by halves of pi. A half of pi, so make pi. Pi is this calzone here. It's half of a circle. So half of pi is 90 degrees, a 90 degree angle. So we're counting by halves. So there's 1 half, 2 halves, 3 halves. So 3 halves of pi is straight down. What is that in degrees? Well, these are 90 degree angles in degrees. So there's 90, 180, 270. What about 5 pi over 3? So we didn't ever count in thirds of pi, but it might be helpful to remember or to think about the sixths of pi. So this is the same thing as 10 pi over 6. It's just reduced. So really we should be counting in sixths. Those are the hours on a clock. So there's 1, 2, 3, 4, 5, 6 pi over 6. Double check, make sure you get pi here so you know you're counting right. So that's 6 sixths. 7, 8, 9, 10. So 10 sixths. Right there. Why is that in degrees? Well, it's 1 sixth, which is 30 degrees, past 270, so that's 300 degrees. And that's all you got to do to find these angles. If it seems confusing right now, don't worry. We'll practice more in class on Monday. We just want to get an intuitive feel for where these angles are. That's going to help us out a whole lot every single day that we talk about trigonometry. So if you're confused, make sure you get yourself unconfused. Ask questions in class, come in for tutorials, watch the lecture video over again, because if you're confused about this stuff, you're going to be confused about everything for most of the rest of the semester. So do something about it as soon as you can. Alright, that's all I got.